All right, here we have an optimization problem. We're trying to, in this case, minimize perimeter because the fencing we have to buy will add on to the perimeter. So if we can buy as little fencing as possible and still lock in 180,000 square meters, we're doing okay. Now we only have 3 sides of a rectangle to worry about. The river is doing the work for us for free on the 4th side. So the perimeter of this rectangle, let's see, I'm going to call this distance x and this distance y, which means this is y as well. So normally for a rectangle we have 2x plus 2y for the perimeter. Here we're only going to have 1x plus 2y because the river is not going to add on to the amount of fence that we need to buy. The area, as our secondary, by the way, this is our primary equation, because this is what we're trying to minimize, is perimeter. The area is fixed. It's got to be 180,000. So I can say x times y equals 180,000, and that is going to be our secondary equation. So we're going to have to, since this is what we're trying to optimize, we are going to have to differentiate it. It would be helpful to make a substitution with one of these variables first before we do the differentiating. So for instance, I could say that y is the same as 180,000 over x by solving this equation for y. So I have to divide away the x, which is where this expression comes from, or this equation comes from. Then I can substitute that back into the primary equation. So now my perimeter, instead of x plus 2y, is x plus 2 times this fraction. Or better yet, x plus 360,000 over x. And since I have to differentiate it, maybe even better yet, would be x plus 360,000 x to the negative first power. Now this is what I need to minimize or optimize. So I'm going to get the derivative of it. X becomes 1. Bringing down, for the second term, bringing down the power brings down a negative 1 times the 360,000 that was already there. This x to the negative first then drops to x to the negative second. I want this derivative to equal 0. And I'm going to call this 360,000 over x squared. And now we do some algebra. I would, you get 2 terms that equal 0, so I'd probably add this term over. You get 360,000 over x squared equals 1. If you cross multiply, you get x squared equals 360,000. Taking the square root of both sides gives you 2 zeros. So 6 and 2 zeros, 600 meters. I know it's plus and minus, but again, you're not going to buy negative fencing. So I'm going to automatically throw out the negative when I take the square root. Again, we should verify that 600 gives you a minimum and not a maximum. So you could do that either by putting 600 on the number line, testing a number left and right in the first derivative, or plugging 600 directly into the second derivative and looking for a positive result. You need to show one of these 2 things is true. I'm going to leave that to you to decide which one. I'd probably go second derivative test, but it doesn't really matter. But you need to do one. But you should get one of these 2 things to be true. Either this is second derivative is positive, or you change on the first derivative from negative to positive, which means p would change from decreasing to increasing. We are looking for the dimensions. Well, we've got the x value. To get the y value, we can go back to the secondary equation. Y equals 180,000 over x. That means now y equals 180,000 over 600. 18 over 6 is 3. 1, 2, 3, 4 zeros. 2 zeros gives you 2 zeros here. We get a rectangle with a 2-to-1 side ratio. What dimensions? So we'd need a 300 meter by 600 meter fenced in area.